Okay, so today we talked about transformations of functions. We are going to be using this form here, y equals a times f of b times x minus c plus d. These are just your different ways to transform. Okay, so each letter represents a different function amongst all of our parent functions. The f of x represents all of our parent functions that we're talking about. So your linear, absolute value, quadratic, logarithmic, and so on. All those from the booklet from the other day. So the very first one is we're dealing with a, and it's going to be a vertical stretch if your a is greater than 0. So if you look, your a is being multiplied on the outside. So I'm going to take y equals, I'm going to pick a number greater than 1, so 2, and I'm just going to pick the parent function x squared. So that 2 is on the outside. It's greater than 1, so this is going to be a vertical stretch by 2. So it's going to take that parabola and it's going to stretch it and make it narrower. Okay, the next part is if your a is in between 0 and 1, so basically if it's a fraction, it's going to vertically shrink it. So let's use the same parent function, quadratic, and I'm going to make it 1/2 this time. So now it's going to be a vertical shrink of 1/2. So it's going to take that parabola and it's going to shrink it vertically and make it flatter and fatter. Okay, also on the outside, if your a is negative, so if there's a negative out front, it's going to reflect over the x-axis. So if I have y equals negative 2 absolute value of x, again, it doesn't matter what the parent function is, it still has the same relation. That negative is what reflects it over the x-axis. So instead of being a V, it's going to be an upside down V because it's reflecting. And the 2 is going to be like what we talked over here. So since it's greater than 1, it's going to be a vertical stretch. So not only is it going to flip over the x-axis, it's now going to stretch and it's going to be a skinnier V. Alright, so there's your A. So if we move on to the B, so now this is talking about multiplying the inside of your function. So actually the x by itself, then it's going to be a horizontal stretch or shrink. So if we look, the stretch is if b is in between 0 and 1, so again if it's a fraction. So if I have y equals the absolute value of 1/2 x, that's going to be a horizontal stretch by 1/2. So it's taking it horizontally and stretching it this way, so it's making it flatter. So your difference between the vertical and horizontal in this case would be that would be a vertical stretch and this is the horizontal. So the difference is it's inside versus outside. Okay, a horizontal shrink would be if your b is greater than 1, so I'm going to choose 2. So y equals the absolute value of 2x. That's going to be a horizontal shrink by 2. So again, I'm taking the horizontal axis and I'm shrinking it inside, so it's making it narrower and skinnier. Okay, if the b is negative, so if it's negative on the inside, it's going to reflect over the x-axis. So if I have y equals, if I'm looking at the opposite version of this, I'm going to have negative on the inside of the bars. Okay, so that negative will reflect over the y. And the 2 is going to be a horizontal shrink. So the negative plays its very own role, and then the number outside is either, since it's on the inside, is a horizontal shrink or stretch. Okay, so there's your A and B. If we move on to the C, we're subtracting C from X moves the graph right C units. Okay, if we look, I'm subtracting here, so if C is positive, it's going to remain negative. So if I had y equals x minus 2 cubed, so my C is technically 2, because when I subtract it from above, that's how it remains, like this. So that means I'm going to move the whole graph right 2. So I'm going to take each point and shift it over 2. Okay, adding C moves the graph left, so if I have y equals x plus 2 squared, again, the parent function doesn't matter, I'm just choosing different ones so you can see that it works all the same. This moves left 2. Okay, and the reason it moves left 2 because technically your C is negative 2. And if I subtract a negative, that's what makes it positive here. So I'm going to move the whole graph to left 2. So your C moves left or right. The D is on the outside. So if we look back up here, it's on the very outside of everything. It's being added. So if I add D to the function, it's going to move up D units. So I have y equals x squared plus 2. That's going to shift everything up 2. Okay, so same thing if I add y equals x squared minus 4. That would shift everything down 4. Okay, so I would just take that whole graph and move it all down. Now, what we need to talk about is your A and your D. Those are on the things on the outside are affecting things vertically. So, stretching it vertically or shifting it up and down. The B and C are on the inside, and that's affecting things horizontally. So, horizontally stretching or shrinking or moving things to the right or left. Now, these last two are probably not going to be on your homework, but still want to introduce them to you and kind of show you what they would do. If we took the absolute value of the entire function, then what it's going to do is it's going to reflect the portion of the graph that's below the x-axis, so whatever is negative, and it's going to reflect it over the x-axis. So basically your graph's not going to have any negative y values. So let's say this is what we started off with. So this part right here is what's negative. So I'm going to take that and I'm going to reflect it above that. So everything else will stay the same. So it's going to go from that, and I'm going to reflect that part that I missed right there, and my arms are going to stay the same. Okay, because basically remember when you take the absolute value, it makes everything that was negative positive. So that's what it's basically doing. Okay, and then the last one, I'm taking the absolute value of just the stuff on the inside of the function. And the portion of the graph that's on the left of the y-axis is going to be erased. And we're going to take it and replace it with the mirror image of the right side. So again, let's say I start off with this graph right here. This is the stuff on the left, so I'm basically going to erase that. So if I erase it, I'm still going to have all of this stuff right here, and I'm going to reflect that over. So that's what your graph would look like there. Okay, so that's what the transformations are. On the back we're going to do a few examples so you have an idea of how we can put all of this into effect. So I'm going to start by writing the equation again so we can look at it and go from there. So I have y equals a times f of b times x minus c plus d. So again, A and D are vertical. A is vertical stretch and shrink. D is moving up and down. B and C are horizontal. B is horizontal stretch or shrink. C is moving it left or right. Okay, these are the three things I want us to do. I want us to name the parent function. So what is it called? And I want us to identify what our A, B, C, and D values are. And then I want us to list the actual transformations in order. So those are the three things we're going to do. So example 1, I have y equals x plus 4 squared minus 2. So when I identify the parent function, I can tell it's quadratic because it's squared. So there's my favorite function, quadratic. The parent function equation is y equals x squared. So that's what I'm basing everything off of. Then I'm going to identify my a, b, c, and d. Since there's not a value up front being multiplied, there is no a. See, multiply right there. There's not a value being multiplied inside, so there's not a b. We are subtracting something. We're subtracting a negative 4. That's what results us in a positive. And then D, we're shifting down to, so the D is also negative 2. So after that, we need to list the transformations. So what do each of those values mean? So the C, if it's minus 4 here and plus 4 here, so I'm going to go left 4. If it's minus 2 on D, I'm going to go down So the very first thing I'm going to do is I'm going to graph the parent function. So I'm going to plot the graph of x squared. Okay, since I know this, and so do y'all, because you're supposed to, I know that that's what the graph looks like. I'm then going to take each of those points that I know, and I'm going to use these transformations and plot my new graph. So I'm going to take each point, I'm going to go left 4 and down 2. So left 1, 2, 3, 4, down 1, 2. So there's that one. And I'm going to do the same thing with the other 2 points. So left 4, down 2. Left 4, down 2. So here, this new one, that's the equation to this graph. So this is your new, that was your old. Okay, so that's how you're going to be doing these. You're going to look for all of the transformations and then graph those. So let's look at another example. So if I have y equals negative 2 to the 2x, first off, this is an exponential parent function. My parent function would be, since there's a 2 as the base, is y equals 2 to the x. My a is negative 1 because it's negative out front. My b is 2 since there's a 2 with the x and it's being multiplied. My c is none because there's nothing being subtracted from the x. And my d is also none because there's nothing being added to the whole thing. Okay, so if we look at what each of these things mean, the negative on the a reflects over the x-axis, and the 2 with the b is a horizontal stretch or shrink, and since it's a 2, it's a horizontal shrink. Alright, so there's what we have. So now I'm going to graph. Okay, I know a couple values of this. I know when x is 0, y is 1, and I know when x is 1, y is 2. So those are the 2 points I'm going to graph. And it looks something like that. And I know that also that there's an asymptote here. Okay, so there's my parent function. So that's your old. So now what we're going to do is we're going to reflect it. So it's going to come down this way. And then I need to figure out what my new point values are. So if I'm horizontally shrinking it by 2, that means I'm making it be flatter. So I'm just going to take the x values that I already know and I'm going to plug it into this. So x is 0. So I have negative 2 to the 0 is 1. And then negative 1. So I'm going to have 0, negative 1. Then if I plug in 1, 2 times 1 is 2. 2 squared is 4. Put the negative back on, negative 4. So at 1 I should be at negative 4. 1, 2, 3, 4. Okay, so there it's reflected and horizontally shrunk. Alright, so there's that. Let's look at one more graphing example. Y equals 1 over x minus 1 plus 5. Okay, if I look, my parent function is reciprocal or rational. Both of those are the same thing. My parent function equation is y equals 1 over x. My a, there's nothing being multiplied out to the side or nothing, not a different number on top. So there's none. My b, there's not a number being multiplied with that x, so there's none. My c, there's something being subtracted from x, so that means it's going to go right 1. Oh, I just need to put 1 since we're writing what the value is. Sorry. And my d is 5. So 3 is where I need to list what it does. So 3, it's going to go right 1, and d, it's going to go up 5. So again, I'm going to draw my parent function. There's asymptotes at x equals 0 and y equals 0. And I know the point 1, 1, negative 1. So it looks like that. So there's your old. Okay, the new, I'm going to take my asymptotes and I'm going to transform my asymptotes. So I'm going to move my asymptotes. So I'm going to move this one right 1. So now I have an asymptote at 1. And then I'm going to shift this one up 5. So 1, 2, 3, 4, 5. Okay, so there's that. And then I'm just going to plot, or I'm going to shift this point right 1, up 5. So it ends up being right in where I wrote. Whoops. So right 1, up 5. So that one is your new. Okay, so whenever you have asymptotes, you should move those if you're shifting left or right, so that they are moved to the correct spot. Alright, last part is going backwards. So, or going the opposite direction. I want you to write equations if I give you what the transformations are. So if I give you the parent function as y equals x, which is linear, and I tell you that it needs to reflect over the x-axis, go left 4, and up 1, I want you to be able to write the equation. So I'm going to start off with y equals, reflect over the x-axis means your a is negative 1, so I'm going to have a negative on the outside. Left 4 means I'm going to have x minus a negative, so it's going to be plus 4. And then up 1 would be plus 1. So here's your reflection, your left 4, your up 1. Okay, the next one, this is the last thing, is I'm going to have the parent function of absolute value, and I want it to have a horizontal shrink of 3, go left 7, and down 4. So again, I'm going to start off with the parent function. Since it's a horizontal shrink, it's going to be inside of the bars. Okay, and since I'm going left 7, I need parentheses around that part, and down 4. So horizontal shrink of 3, left 7, down 4. So there's that. Your homework for this is a worksheet, and there are a couple ones that you need to graph. So remember, graph numbers 2, 4, 7, 8, and 9 on the back or either graph paper. Alright, good luck. Please, if you have questions, come see me in tutorials.